Hello everyone. So in this video again we have come up with a very unique question pertaining to logs. So let's go through. There is a unique positive real number x second, such that three number log 8 2x. Okay, just let me darken my pen a bit. Log 8 2x, log 4x, and log base 8 2x, log base 4x, and log base 2x in that order form a geometric progression. Okay, with positive common ratio. A number can be written, number x can be written in m by n form where m and n are positive integer. So find the value of m plus n. Okay, so before we get into the problem, let's try to understand what geometric progression terms. Let me give you a brief idea on the term itself. Okay, so here suppose I say I take a GP term, say 2, 4, and 8. Okay, the common ratio here is 2. Again, here is 2. So a very good property pertaining to GP is that 4 will be root under 2 into 8. Okay, so this is the general idea behind a GP, because the middle term would be the root of the next two term. So if I take a look in the question itself, then what I can see is that here the common ratio would be log base 2x by log base 4x. Okay, so this can be further written as, if I am to change the base, so I can write it in this form: 2x by log base 4x. Okay, log x base 4 by log x base 2. Okay, so I can write it in this way. This I have actually written by using the formula log a base x equal to 1 by log x base a. So I've used this property of the log in general. So now if I have to go ahead with the process itself, so next up we can actually further write this in, I'm changing the base to log 2 base 4. Okay, so I can write this, so which should actually give us, okay, sorry, my bad. I can further write this as log 2 base 4, which will actually give us 2. I'm just changing the base of the same. So this one, so this particular thing I have written by using the log property, which is log a, log base a x equal to log x base b by log a base b. So I've used this particular basically property of log, and I've basically converted the same. So therefore with this we can conclude that common ratio, or I'm denoting it by R, is equal to 2. Now okay, now what we'll do is log base 4x by log base 8 twice x is equal to 2. I can write it from there, which I can further write log base 4x equal to 2 log base 8 2 plus 2 log base x. Okay, so I hope this much is because I can write it 2 into x, so log a plus log b, I can write it in that form. So I've just split this one out. Okay, this can be further written as log x base 4x can be further written as 1 by 2 log base 2x. Okay, so which should basically give me 2 by 3 plus 2 by 3 log base 2x. Okay, subsequently I hope this much is clear. So if you're wondering how we arrived from log base 4x to log 2x, so this again uses another log property which basically states log a to the power kx equal to 1 by k log ax. Okay, so similarly, so if I'm to take a look here, log 2 square 4 we can like it 2 4x, so I can write 1 by 2 log 2x. So this is the formula that I have actually used. So I hope everything is clear until up until now. So next up we can again carry this forward with minus 1 by 6 log 2x would be equal to, simply I have taken this particular term here, I've taken it here, so minus would come. So this simple basic equation solving equal to 2 by 3. Alright, so this can be further written as log base 2 x equal to minus 4. So then in turn x will come out to be 1 by 16. So here in this 1 by 16 we have 1 is equal to m, 16 is equal to n. So therefore m plus n is equal to 1 plus 16 equal to 17. So I hope this problem is clear to you, the various approaches we have taken towards solving the same. So kindly go through this, try and practice the same. We have simply used the different log properties in general to give you an idea about how we go about solving this. So with that said, I'm signing off. Thank you so much.